Welcome to Astronomy Daily. I'm Anna, and we've got another absolutely packed show for you today, covering some of the most exciting developments in space and astronomy. From groundbreaking observations by the James Webb Space Telescope that are giving us new insights into the early universe, to fascinating discoveries about black holes that are changing our understanding of these mysterious cosmic objects. We'll also explore some major developments in space exploration, including ambitious new plans for mining operations on the moon, and an unexpected new chapter in the story of NASA's pioneering Mars helicopter. Plus, we'll look at how events in space are affecting life right here on Earth in some surprising ways. So get ready for a journey through the latest and most intriguing space news as we explore the cutting edge of astronomical research and space exploration together. The James Webb Space Telescope has given us a remarkable glimpse into the early universe with its latest observation of a galaxy whimsically named Firefly Sparkle. And this galaxy isn't alone. It's accompanied by two companion galaxies that scientists have playfully dubbed Firefly Best Friend and Firefly New Best Friend. What makes this discovery particularly exciting is that we're seeing this galaxy as it appeared when the universe was just 600 million years old. That's less than 5% of its current age of 13.8 billion years. Thanks to a phenomenon called redshift, which occurs when light is stretched by the expansion of space itself, astronomers were able to determine just how far back in time we're looking. The observation was made possible by a cosmic magnifying glass effect. The galaxy cluster, MAXJ, 1423, 8 plus 2404 sits between Earth and Firefly Sparkle, and its immense mass bends and magnifies the light from behind it, giving us an enhanced view of this distant galaxy. When combined with Webb's incredible sensitivity, this gravitational lensing allowed scientists to study Firefly Sparkle in unprecedented detail. What they found was fascinating. Most of the galaxy's mass is concentrated in just 10 star clusters, making it the most distant galaxy with well-resolved star clusters ever observed using spectrographic instruments. The galaxy is rich in gas and has a total mass about 10 million times that of our Sun, similar in size to what we think the early Milky Way might have been like. This makes Firefly Sparkle an invaluable window into our own galaxy's past, potentially helping us understand how our cosmic home formed and evolved in its earliest days. It's like finding a baby picture of our own Milky Way, giving us crucial insights into galaxy formation in the very young universe. Next, in an exciting breakthrough for black hole research, NASA's Imaging X-ray Polarimetry Explorer, or IXPE, has provided us with unprecedented details about a newly discovered black hole system. The stellar mass black hole, part of the binary system Swift-J 1727, made quite an entrance when it was discovered in summer 2023, briefly becoming one of the brightest X-ray sources in our sky. Located just 8,800 light-years from Earth, this cosmic neighbor gave astronomers a front-row seat to observe the complete life cycle of a black hole outburst. The system went from first detection to peak brightness in just a matter of days, allowing scientists to study its evolution from start to finish with remarkable precision. What makes this discovery particularly significant is how IXPE helped us understand the shapes of two crucial structures around the black hole: its accretion disk, where material swirls before being consumed, and its corona, a region of superheated plasma. Using X-ray polarization, a special characteristic of light that reveals the geometry of these distant objects, IXPE showed us that the hot plasma extends along the plane of the accretion disk. The observations revealed that despite dramatic changes in the system's brightness and energy output, the basic structure of these features remained surprisingly stable throughout the outburst. This consistency across different phases of activity gives us valuable insights into how black holes behave and interact with their surroundings. This binary system operates like a cosmic recycling center. The black hole strips material from its companion star, heating it to temperatures exceeding 1.8 million degrees Fahrenheit. This process creates an intense outpouring of X-rays and forms various structures around the black hole that we can study, even though we can't see the black hole itself. These findings represent a significant step forward in our understanding of black hole systems and demonstrate how modern instruments like IXPE are revolutionizing our ability to study these mysterious cosmic objects. By combining observations from multiple telescopes and instruments, we're building an increasingly detailed picture of how matter behaves in the most extreme environments in our universe. In a remarkable demonstration of planetary defense capabilities, China's Yunnan Observatories has achieved something quite extraordinary, tracking an asteroid from its initial detection all the way through to its dramatic finale in Earth's atmosphere. Using their impressive 2.4-meter telescope, the largest of its kind in East Asia, astronomers at the Lijiang Observatory spotted asteroid 2024 XA1 on December 3rd. What makes this detection particularly noteworthy is the incredibly short timeline involved. The team had less than 12 hours from first spotting the asteroid to its fiery entry into Earth's atmosphere over eastern Siberia. During those crucial hours, the research team developed a precise observation strategy, carefully considering the asteroid's trajectory and velocity to maximize their tracking accuracy. The observatory's location proved to be a key advantage in this achievement. Situated more than 3,200 meters above sea level and at a strategically beneficial latitude, the facility offers some of China's clearest views of the cosmos. Their advanced telescope system is specifically designed to track fast-moving objects like near-Earth asteroids with exceptional precision. During the final hour before the asteroid's descent, the team successfully captured detailed images of the object. The asteroid's journey concluded with a spectacular fireball as it burned up in Earth's atmosphere over Siberia around midnight on December 4th. This kind of end-to-end tracking of a near-Earth asteroid provides crucial data for improving our planetary defense capabilities. This achievement highlights the growing importance of early warning systems for near-Earth objects. As we continue to enhance our ability to detect and track potential threats, observations like these provide valuable real-world experience in monitoring objects that could pose risks to our planet. It's a reminder that maintaining vigilant sky surveillance isn't just about scientific curiosity, it's an essential component of protecting Earth from potential cosmic hazards. A fascinating development in lunar exploration and resource utilization is taking shape as Japanese lunar exploration company, iSpace, and lunar prospecting company, Magna Petra, join forces. The two companies have recently signed a memorandum of understanding to collaborate on what could be a game-changing venture: the extraction of helium-3 from the moon's surface. This partnership comes at a crucial time, as iSpace prepares for its second attempt at a lunar landing. Their previous mission ended in a crash due to an altitude sensor malfunction, but the company has made significant improvements to their lander's software for this upcoming attempt. The new mission, scheduled for January 2025, will deploy their Resilience lunar lander carrying the Tenacious micro rover, designed to demonstrate capabilities in traversing lunar terrain and collecting regolith samples. What makes this partnership particularly intriguing is its focus on helium-3, a resource that's incredibly scarce on Earth but potentially abundant on the moon. Magna Petra's ambitious plan involves what they call non-destructive, sustainable harvesting methods to extract commercial quantities of this valuable isotope. Once extracted, they aim to transport it back to Earth, where there's currently an extreme supply shortage. The company's approach emphasizes the importance of developing proper infrastructure for lunar operations. As Magna Petra's CEO Jeffrey Max points out, such missions require reliable cislunar transportation and robust lunar infrastructure. iSpace's track record of innovation and global presence makes them an ideal partner for this ambitious undertaking. This collaboration represents more than just a mining operation. It's a significant step toward establishing a sustainable lunar economy. As iSpace's founder Takeshi Hakamada notes, while water ice at the lunar poles has grabbed most of the headlines, the moon harbors many other valuable resources that could play crucial roles in future space exploration and development. While Ingenuity's historic flights on Mars may have come to an end, NASA's remarkable little helicopter isn't quite finished with its mission yet. After suffering rotor damage during its 72nd flight this January, the team at NASA's Jet Propulsion Laboratory has found an innovative way to keep their pioneering aircraft contributing to Mars exploration. Despite the crash landing, JPL scientists have discovered that Ingenuity remains in surprisingly good health. All of its avionics, battery systems, and sensors continue to function normally. In fact, if you were to check Ingenuity's own diagnostic systems, they would show everything operating perfectly. the helicopter simply isn't aware of its damaged rotors. This unexpected durability has opened up an exciting new chapter for Ingenuity. The team has announced that the helicopter will be repurposed as a stationary weather station, capable of recording telemetry and capturing images every Martian day. Even more impressive is that Ingenuity has enough onboard storage to potentially continue this new mission for up to 20 years. The investigation into Ingenuity's final flight revealed that the crash occurred due to the navigation systems struggling with the monotone, bland texture of the Martian surface. While the full details may never be known, given the accident site is over 100 million miles away with no black box or direct access, the team has completed what they're calling the first aircraft investigation on another world. There is one significant challenge ahead, though. Ingenuity relies on the Perseverance rover as a communication relay to send data back to Earth. With the rover now 1.8 miles away and continuing its own mission, the team expects they may lose contact with Ingenuity within the next month. However, there's an intriguing possibility that future Mars missions, whether robotic or human, might one day be able to recover the valuable data Ingenuity continues to collect. Our reliance on modern technology has created some unexpected vulnerabilities, and nowhere is this more apparent than in today's high-tech farming operations. A series of powerful solar storms in 2024 revealed just how dependent our agricultural sector has become on GPS systems, and how easily these systems can be disrupted by solar activity. Consider what happened on May 10th when the sun unleashed its largest geomagnetic storm in decades. While many people were mesmerized by the spectacular auroras lighting up the sky, farmers across the American Midwest were dealing with what one aurora chaser described as demon-possessed tractors. These sophisticated machines, normally precise in their movements, began lurching unpredictably across fields as their GPS guidance systems went haywire. Modern farming relies heavily on GPS-guided tractors for planting crops in perfectly straight rows and applying precise amounts of fertilizer. This technology has revolutionized agriculture, dramatically improving efficiency and reducing waste. But when solar storms interfere with GPS signals by disturbing Earth's ionosphere, these carefully calibrated systems can become completely unreliable. The impact wasn't limited to that single event in May. Later in October, more solar storms caused similar problems during the critical harvest season. Farmers reported their automated systems jumping lines and veering off course, forcing them to switch to manual controls or halt operations entirely. With an estimated 80% of Midwest farmers using GPS technology for at least some aspects of their operation, and about half being heavily dependent on it, these disruptions can have serious consequences for agricultural productivity. The timing of these solar storms can be particularly crucial. A delay of just 3 or 4 days during key planting or harvesting windows can significantly impact crop yields. What's more concerning is that these disruptions are likely to become more frequent as we approach solar maximum, a period of heightened solar activity in the sun's 11-year cycle. This vulnerability has sparked discussions about developing more resilient farming technologies. Some experts are now looking toward systems that combine machine vision, artificial intelligence, and expert guidance systems to reduce dependence on GPS alone. It's a reminder that as we advance technologically, we must always consider our connection to and dependence on the natural world, even the activities of our own star. Well, that brings us to the end of today's episode of Astronomy Daily. I'm Anna, and it's been my pleasure bringing you these fascinating stories from the cosmos. From young galaxies in the early universe to the surprising ways solar storms affect our farms here on Earth, it's amazing how interconnected our universe truly is. If you'd like to stay up to date with all the latest developments in space and astronomy, I invite you to visit our website at astronomydaily.io. There, you can sign up for our free daily newsletter and access our constantly updating newsfeed of space and astronomy news. You'll also find all our previous episodes available for streaming. Want to join our community of space enthusiasts? You can find us across all major social media platforms. Just search for Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. We love hearing your thoughts and questions about the cosmos. Until next time, keep looking up and wondering about the mysteries of space. This has been Astronomy Daily, and I'm Anna. Thanks for listening.